Today, we are diving into a new kind of AI. Seriously, this is different. It's an architecture that's not just trying to model the world around us, but also the mind that's actually experiencing it. And no, this isn't science fiction. It's a new approach that could completely redefine things like augmented reality. Think about it. Augmented reality is this incredible promise, right? But using it often feels a bit disjointed. There's that tiny lag, that sense that it can't quite figure out what you're about to do. You know, it always feels like the system is playing catch-up and it's always one step behind. So why is that? Well, the problem is really in how these systems are built. They're basically a patchwork of separate, siloed processes. You've got one program handling SLAM, that's just building a map of the room. You've got another one just for tracking your hands, a third for your eyes, and a fourth trying to understand what objects are. They're all working in their own little bubbles, which is super inefficient, and it's what leads to that clunky feeling. The new vision? It's to throw all that out and replace it with a single, unified system that models both you and your environment, all at the same time. So, how in the world do you build a unified system like that? Well, the answer comes from an architecture that's actually inspired by the human brain. It's called frequency-governed self-graph reasoning, or let's just call it Fgsgr for short. Okay, so Fgsgr is built on 4 really key ideas. First, you've got this tri-frequency hierarchy, which just means it processes information at different speeds, kind of like our own brains do. Second, there's graph reasoning, which lets it connect ideas and even model its own thought processes. Third, it's all about predictive processing. It's constantly guessing what's going to happen next and then learning from its mistakes. And finally, it has a built-in safety system to make sure it all works together reliably. Let's just focus on that first idea for a second, because it's really the foundation of everything. Fgsgr takes all the information coming in from cameras, from sensors, you name it, and it splits it into different frequencies. Think of it like an EEG reading brainwaves. And this isn't just some clever engineering trick. It's designed to mirror how our own brains handle information on totally different scales and at different speeds. Let's break those frequencies down. At the fastest level, you've got the gamma band. This is for your immediate split-second reflexive stuff. In the middle, the alpha and beta bands are managing what you're doing right now, identifying patterns. And then at the slowest, deepest level, you have the theta band. This is the big picture stuff, your long-term goals, your memories, the overall context of what's happening. Now, this is where the story gets really fascinating. The researchers who built this Fgsgr architecture, they did it based on practical engineering principles. But then, they had this huge aha moment. They discovered that their design, their creation, almost perfectly mirrored this profound theory from neuroscience about how all intelligence, all of it, actually works. And that theory is called active inference. The core idea is just stunningly simple. It basically says that every intelligent system, from a tiny cell all the way up to a human brain, has one fundamental goal: to minimize surprise. That's it. Everything we do, seeing, thinking, acting, it's all in service of making the world more predictable. We build models of reality just so we can get better at predicting what's going to happen next. And here is the real kicker. Fgsgr wasn't even built on this theory. It just turned out to be a perfect real-world application of it by accident. And by making that connection official, as the source material points out, the researchers basically unlocked a whole new level of potential for the entire system. And just look at the slide, because it shows you how deep this connection really is. This isn't a metaphor. On the left, you see the Fgsgr components we've been talking about, and on the right, that's the hardcore math behind active inference. And it's a direct one-to-one mapping. They are literally 2 sides of the exact same coin. You realize what this means, right? This is a massive paradigm shift. Fgsgr goes from being just a clever piece of engineering with a bunch of knobs you have to tune, to being a single, unified architecture that comes from one fundamental principle of the universe: minimize surprise, or what the mathematicians call free energy. Suddenly, every single part of the system is working toward the exact same goal. Okay, so that's the high-level theory. But how does this elegant new architecture actually fix our clunky AR systems? Let's bring this back down to earth and see how it really translates into a better experience. So the real payoff is that Fgsr can basically replace the entire conventional AR software stack. Each part of it maps directly to a core function. The tri-frequency system, that handles fusing all the sensor data together. The graph reasoning, that builds the 3D scene in real time. The back-channeling, that's what allows the system to understand the user and the environment as one unified thing. It's a complete top-to-bottom overhaul. So Instead of that clunky, inefficient mess of separate pipelines that we started with, we now have one elegant, unified system. And it's not just modeling the world anymore, it's modeling the combined system of the user and the world as a single, indivisible whole. And this unification unlocks some incredible new abilities. Take a look at this idea of bidirectional inference. Let's say you want to pick up a cup. The old system just sees your hand moving. This system, though, it infers your intent. It gets that you want the cup. And from that high-level goal, it generates a top-down prediction of how your hand and your eyes will most likely move. That prediction then makes the bottom-up sensor tracking way faster and way more accurate. It's not just reacting to you anymore, it's anticipating you. But the implications here go so much further than just smoother AR. This unified approach, well, it leads to something emerging from the system that is truly profound.
Once you have a system that is powerful enough to create a coherent, predictive model of the physical world around it,
It can use that exact same architecture to model the mind that is perceiving and acting within that world. And this leads us to this incredible concept, a cognitive digital twin, an AI that maintains a real-time, constantly updated model of you, your attention, your intentions, your goals, maybe even your personality. And what's amazing is that Fgsgr's tri-frequency architecture is perfectly suited for this. That slow alpha band, it can model your stable long-term traits. The medium beta band can track your current tasks and goals. And that super fast gamma band can monitor your moment-to-moment attention. The AI is literally modeling you on the same timescales that your own brain operates on. So all of this leads to one final huge question. We started this whole journey by trying to fix clunky AR, but this architecture has taken us somewhere far deeper. It creates a potential future where our devices don't just see the world, they actually understand our place in it, which forces us all to ask, what happens when our technology stops just reacting to our commands and starts to actually understand how we think?